Sketch the graph of y equals 2 sine of x minus root 3 for x is an element of 0 to 4 pi. Clearly label all axial intercepts, maximums and minimums with their coordinates. So as you can see, the domain in which we're graphing it over is 0 to 4 pi, and the period of this graph is equal to 2 pi over n, but the n is the value that multiplies by the x, so it's just 1, so it's just 2 pi. So with that in mind, there's going to be 2 full cycles of the sine function on this graph. So before we go and find all of the key features and their exact values, we'll just get a feel for where this graph is going to be. So if we were to graph 2 sine of x, it might be something like this. Then all we're going to do is we're going to take that and move it down. So we're going to translate it root 3 in the negative y direction, and that will be the finished graph. So I'm going to take that one off, and then once it's translated down, the new graph is going to look something like this. So that is 2 sine x minus root 3. So it's just the 2 sine x graph translated the square root of 3 in the negative y direction. And now our job is to go and find key features such as the y-intercept, the endpoint, the x-intercepts here, 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 and here, as well as the maximums, which occur here and here, and the minimums, which are down the bottom of our graph. So we're going to start by finding the y-intercept, and the y-intercept occurs when x is equal to 0. So when x is equal to 0, our rule will become y is equal to 2 sine of 0 minus root 3. But we know that sine of 0 is just 0, so we know y is just going to equal negative root 3. Therefore, the coordinate of the y-intercept is going to be 0 minus root 3. So that's this coordinate here at 0, minus root 3. Next, we're going to find the other endpoint, and that is at x is equal to positive 4 pi. So that's going to leave us with y is equal to 2 times sine of 4 pi minus root 3. But sine of 4 pi is just 0. So once again, we have y equals 2 times 0, so it's just minus root 3. And that gives us the coordinate 4 pi, negative root 3, which is this endpoint here at 4 pi, negative root 3. So they are the two endpoints, one of which happens to be the y-intercept as well. And now we're going to find our x-intercepts. And these occur when y is equal to 0. So the equation we're going to solve is 0 is equal to 2 sine of x minus root 3. And then rearranging that to get sine x by itself, we're going to add root 3 and divide by 2. So we're going to solve sine of x is equal to positive root 3 on 2. And now the reference angle you should know for that is pi on 3. And that sine is positive in the first and second quadrants. So there's actually been another video done on finding these values by hand. And in that video, we reached the conclusion that x was equal to pi on 3, 2 pi on 3, 7 pi on 3, and 8 pi on 3. So they are going to be all of the x-intercepts. So it's going to be in coordinate form pi on 3, 0. Then this one's going to be 2 pi on 3, 0. This will be 7 pi on 3, 0. And finally, 8 pi on 3, 0. So they are the 4 x-intercepts of this graph. Our next job is to find the maximums. So because of the way that the sine and cosine curves are in fact symmetric, we can find the maximums by finding the average of 2 x-intercepts that it lies between. So if we take the average of pi on 3 and add 2 pi on 3, and divide by 2, so that will get the average. If we calculate that, we'll have pi on 3 plus 2 pi on 3 is 3 pi on 3, and then dividing by 2 will give 3 pi on 6, which is in fact pi on 2. So the coordinate of this maximum is going to be pi on 2, and then the maximum height will be negative root 3, which is the translation down, and then add the amplitude. So it's going to be 2 minus root 3 is that value there. Now to find the next one, we don't have to go through that process again. We can simply take that x value and we can add the period to it. And of course, that's the same as just adding 2 pi, because that's what we found the period to be up here. So the x value is going to be pi on 2 plus 2 pi, which is 5 pi on 2, comma, and the y value will be the same. So it's going to be 2 minus root 3 again. And finally, we're going to find our minimums in exactly the same way. So this time we're going to take the average of 2 pi on 3 and 7 pi on 3. And that value will be the x value of the minimum. So we're going to have 2 pi on 3 and add 7 pi on 3 and divide that result by 2. And now 2 pi on 3 plus 7 pi on 3 is 9 pi on 3, which is just 3 pi. And then we divide 3 pi by 2, and that's the x value. So the coordinate of this minimum is 3 pi on 2, comma, and this time we're going to have negative root 3 minus 2 as the y value. So it's minus 2 minus root 3. Once again, we don't have to find the averages again. We can just add a period on. And adding the period is the same as adding 2 pi, because that's the period of sine of x. So adding 2 pi to 3 pi on 2 will give 7 pi on 2 as the x value, and the y value will remain the same. So it's going to be minus 2 minus root 3. So that is the full graph with all maximum minimums and axial intercepts labelled with their coordinates. Just quickly on this slide, we've got a computer to generate exactly the same thing, and you can see that all of the key features are the same as what we found on the previous slide.